So we will be we'll be talking about sort of all the different functions in the Tidyverse that you'll need to sort of know for you to do your assignment, and some extra functions that you might find useful or helpful in your dissertation, or just sort of generally when cleaning up data. And so this will kind of be like a guided walkthrough of some of that code. Normally the lectures, especially when we get onto statistical content, will be a little bit more driven by a whiteboard. I'll be kind of writing out or drawing equations and graphs and things. But today, just because the content in this first block is so kind of nuts and bolts of working with R, the lecture will primarily be me demonstrating how to do things wrong. So if you are already confident or don't really want to learn more about how to use tidy tools and tidy transformations and things like that, then you do not have to continue attending the lecture. So I just like to say that straight up front. The second thing is, in the chat, Edward has noted that there is a discussion board on Blackboard where you post your questions, and I have put that on my website, but I have not surfaced that on the Blackboard. So later today, I'll make sure that the discussion forum is posted clearly in the Blackboard site. But if you check the chat history and you check you check the quick links on my website, you will see how to get there. I have just recently found this morning that all new notifications about things that are posted on there are going to my spam. So many of you have used this discussion board and I haven't been aware that you have. So I'm not sure why that's happening, but I'll try and make sure to check these during my office hours on Monday to make sure that all questions are answered. Because I know some students appreciate the opportunity to ask questions anonymously and get timely answers to those. So yeah, if there's any other kind of questions about course logistics or kind of points of information that we can address. Okay, if there's not, then I think we'll move forward to doing some of this tidy transformation stuff. For the final topic block, great question, Matthew and James. So for the final topic block, what are some possible things we could cover? Okay, well, pretty much anything that you find in either book, so either your ISL or your Gelman, either one of these. Any topic you see there, I'm comfortable covering, as well as sort of like, there are some sort of soft skills that some people like learning how to use program version control or learning how to use GitHub, things like that as well. So there's a wide variety of kind of digital literacy practices that I'm also able to cover. Things that would be reasonable to cover would be things like generalized additive models, which are another, we'll get to one kind of generalized linear model soon, but a generalized additive model is able to fit extremely nonlinear curves, and they can be incredibly useful in the analysis of data where what is fitting a trend line rather than animating any underlying parameters. Sophia, I'll get to that in a second. The ended sort of lecture material on the last block would have been chapter 10 in the Introduction to Statistical Learning. So that would involve a little bit about the concept of principal components analysis, clustering. These are techniques known as unsupervised learning, which we'll have a longer lecture on next week. But basically, they're not methods that are intended to predict outcomes. They're methods to find latent structure in your data when you don't know what kind of outcome you're predicting. So like one common example would be in a remotely sensed image. Sometimes they use a clustering method on pixels to try and find pixels that look similar to one another. They have the same RGB values. We use clustering in human geography in the practice of what's known as demographics, geodemographics. So geodemographics is where you're trying to abstract large, complicated data sets about human beings into kind of like abstract types of humans. So you could say this neighborhood is full of young and upcoming professionals, and this neighborhood maybe is older retired people, and this neighborhood maybe is young striving families, and that kind of thing. So unsupervised learning is a way to kind of introduce structure into your data when you don't have a y variable. So that was what I had intended to cover, because we talk a lot in geography about supervised learning, but you've never really learned a lot about unsupervised learning. So again, anything that's in ISL or data analysis using regression is a valid target for that last chunk. Sophia, will you put answers to the exercises we're on the readings? Don't know if you have them, thanks. So you're talking about the kind of exercises in like the Gelman or in the Hadley book. I'm happy to talk over the questions in office hour, but I will not be posting answers to exercises that are not my own, if that makes sense. So if you see a problem in the Gelman that you don't understand, come talk to me, or talk to your friends, or talk to your TAs. But I will post my answers and only mine. So, Lauren, do you have feedback of previous year's work that we could get access to? So I do, but I'm not super comfortable sharing it because it's substantially, sometimes the code structure is very similar to what we're doing, even though the data's been updated and the exposition's been updated. I'm kind of loath to spread that around. So yeah, I would suggest that you kind of get a better sense of what you're looking for, maybe individually, or you could like show me a copy of your assignment and I can tell you, that's about enough exposition, if you're comfortable with that. Like I said, it's usually only 1 or 2 sentences max, unless I really sort of hammer home, please fully interpret what this model means and give me a paragraph about, your thoughts. Most of the time, answers should be 1 or 2 sentences, maybe max 5. Cool. Great. Okay. Are there any other questions about logistics and other kinds of things here? I love that you're coming to class with these questions. It's my favorite kind of teaching style is to open up with questions either about course content or course structure. So I'm very happy when you come with the questions that you would otherwise post online to the lecture. Okay, so if there are no further questions, I'd like to move on to, is there any benefit in reading both ISL and ARM versions on topics? As we'll talk about next week, it's less of a benefit or a problem and more of a philosophical and conceptual difference in language. Gelman, the ARM book, is very much coming from a social science perspective. So they're presenting very clearly, if you're a social scientist, this is generally what you want to focus on. The Gelman book tends to have more language, like more writing physically. And the ISL is much more from kind of a computing background. So the authors of the Intro to Statistical Learning are all either computational statisticians or computer scientists who have a much more kind of data scientific approach to doing analysis. So Gelman is what I would describe as classic text, and ISL is kind of the new way some of these things are taught and explained. My suggestion would be that in the cases where there's reading from both, pick your favorite. So if you think Gelman explains things more clearly than ISL, go with that. As long as you get the concept from the reading, there's nothing specific to either that will that will benefit you or harm you. So it's just extremely different ways of presenting similar material. And I've demonstrated those links at the end of the syllabus. So I should say, like, you know, for the reading on the regression part, there's an equivalent chapter in ISL that will give you an overview as well. So I don't mind which one you do. My recommendation is what is in the schedule. But if you find that you like the Gelman more than the ISL, or you like ISL more than the Gelman, just make sure you read the corresponding literature and you'll be okay. Okay? Does anybody else have any questions? I have road work going on out front of my apartment today, so there's a lot of background noise that I hope is not showing up on the recording. Okay. If everybody is satisfied on those collections of answers, I would like to move on to the content. My recommendation today might actually be bringing up our, on your own computers, so that you can work through some of these transformations and examples with me, and then we'll kind of proceed. So what I'm going to do is share my RStudio. There we go. Unfortunately, I'm not able to annotate the screen in Blackboard Collaborate in the same way. In order for me to do that, I have to be on a whiteboard. So I'm not able to highlight what's going on, but I'll try and do it with the mouse, and it'll hopefully be effective. I'm also watching the chat as this is as the lecture goes. So you know, if you have questions, just immediately pop them in the chat, and I'm happy to work with them. So the first thing that I would recommend doing or learning is, I put in the chat, I'll put it on Blackboard as well. There is a whole kind of cheat sheet that describes the different kinds of operations that you can use to manipulate data in the Tidyverse. So lots of these different kind of verbs are interrelated, and sometimes you'll find kind of inverses of one another. So today, I just want to walk you through a couple of different kinds of transformations and give you a vocabulary for doing those manipulations. If you've done the reading already, you'll recognize many of these transformations, but some of them you will not. Some of them are not in the reading. So to proceed, let's first start by reading in our data. So the first thing I'm going to do is read in temps. The temperature data that we've been using the whole time, and that you should recognize. Is this text large enough for students? Can you see? Yep. Okay, cool, thanks. So the temperature data, and I'd also like to read in the species data. So that is species is equal to read CSV data species.csv. Okay, so you've seen these two data sets before, right? And with the temperature data, we recall that it has this issue where the columns are month names, and in a tidy data, we want to make sure that all of our columns are just one variable. So right now, we've mixed up a variable, which is what month we're in, across the columns. So this data is not in a tidy format, according to R. So the last time we worked on this, we did something like this, where we did a pivot, and we used the columns from January to December. We refer to their destination for those columns as month. and we put the values that they contain into a column called temperature. Does everybody recall that? I'm sure you do. So last time I encouraged us to do long temps as the name. And then also in the workbook, I suggest that we have species, pivot longer, and we do something like A robusta to S Florida, values to equals prevalence, because each of the elements in those cells is a prevalence value of organisms per 1,000 milliliters. And we want to put the names to species name. And this would be our tidied version of the data. Yeah, good. So first off, if this is our now tidied version of the species data, then the original data isn't really measuring species. Patrick, the markdown, I can make these lecture notes available, yeah, but the actual code that I'm writing is all novel. So I'll post that if you'd like later. But it's not in the workbook, and it's not anywhere. So I've got it saved, so don't worry, and it'll go up. So the original data for the species is actually not about individual species. Each row actually represents one site or one measurement, right? So even though I've called the CSV species, and I read it in and called it species in memory, you can see here that row 1 is referring to a measurement at a particular location, at a specific latitude and longitude and date, at a given depth. And then row 2 is that same date, that same position, but at a deeper depth. So in fact, the species data frame isn't really about species, it's about sites. And a more reasonable name for the species data frame might be what we did up here when we pivoted. So I'm going to rename the species data to be the long version, which looks like this, where we have the species name column on the right. And I'm going to refer to the sites data as the ones with the species in the columns. Okay? So sites, because these are measuring at individual points in time and space, and I guess depth. And the species column refers to the measurements pertaining to one species at one point in time. Okay? So the first thing I want to show you is how to reverse between the two pivots. So the long temperature data. We have 3 columns, and we might actually want to spread this out into its original form. Sometimes this operation is reversible. So if you do long temps, pivot wider. For the pivot wider, we need to tell where the new columns are going to come from and where the new values are going to come from. So in this case, we want new columns to pertain to the month column. So we would do names from month. And if we want the values for those columns to come from the temperature one, we would do values from equals temperature. And if we do that, we get back to our original data. Does everybody see that? The pivot long takes us down, and the pivot wide, or pivot wider, takes us out. I could have just as easily done names from here. If I were to do this, my data frame would have years on the top, on columns, and rows would be the month. So pivot wider takes you from the long form and spreads everything out over columns. This is why in older versions of RStudio and some of the code, pivot wider was called spread, and pivot long was called gather. RStudio has moved away from that, but some of their documentation still refers to pivot wider as spread and pivot longer as gather. If you check out the cheat sheet that I've posted in the chat and also on Blackboard, they'll use gather and spread where they're using pivot wider and pivot longer. So I just wanted to clear that up because I got some questions about that. Now, one of the interesting things about pivots is that you can use them to summarize data. So in the case of our species data, I have a bunch of rows that have sort of duplicated values. And if I wanted to spread that back, I might say pivot wider, names from species name, and values from prevalence, just like before. But do you see at the end here, in this A robusta column, I've got this weird list type of input. Okay? This is because a pivot wider can actually collect more values than can be stored in a cell in R. When you go long, you're always squashing everything into individual rows. But when you want to push things wide, you may end up with a case that multiple values occur in one row. Does that make sense to everybody? Can everybody see what I'm referring to here with this double one? That means that R thinks that there's more than one value in that cell, so it's treating it as a list of values. So when you do a pivot wider, you can actually use summary functions to change the output of the cells. You do that using the values function. So this argument says, if I have multiple values in each row, then compute some summary from them and use that as the value of the row. So here, if I used mean, then I would get back the mean value of any duplicated cells that fall over on the right. And in this case, because I know that the match is close to 1-to-1, this will basically give you the correct answer that you have in the original site table. So the point is, sometimes your pivot wider has too much information to stuff in your new rows. So if you want to summarize that collection of values, you use the values underscore function argument. So it lets you compute summaries, sometimes called pivot tables, from input tidy data that are nice single number summaries. And you may see, like if you look online, there are plenty of things about using pivot tables to do business analytics and tons of things in like Excel on how to make pivot tables. In R, it's very simple, but you just have these values functions that let you manipulate what comes out, okay? But the main point is I wanted to show, yeah, Hannah, the main point is to show how the pivot wider can result in this happening and how you can summarize it. So to show how this happens, to help show how this happens, Hannah, I'm gonna do one more thing and then show you more explicitly how the multiple values can be created, okay? So if I have the species data again here, one helpful thing that you can do, so you see how the species name in each cell is composed of two parts. The first letter is the genus of the organism, and the second part, after the period and space, is the actual species name. In R, we can use a function called separate to split columns that have more than one value in them. So if we were to separate the species name into the genus and the organism, we would do something like this. We would say we want to separate the species name column, and we want it to become genus and organism. And the actual separator that we want to use to split is a period and a space. So what this will do is it'll look through all of those names, split them whenever they see a period and a space, put the thing on the left into genus, and put the thing on the right into organism as new columns. So the separate function now gives us those two columns on the right, genus and organism. Does everybody see that? The genus column is now composed of A, C, E, G, and S, which are the genuses of the individual organisms, and the organism names are now in the organism column. So separate takes one column and splits it into two columns. The analog of that is separate row, which splits things along the separator into new rows. So this one is not particularly helpful in this case, but it could be helpful in other cases. So you see here how if I run separate rows, separating species name on that dot, I now get two rows for every single row in my original data frame. Just to show them side by side again, I'll do species and then the new measurement. So do you see how row 1 and 2 in the lower data frame is the same as row 1 in the upper data frame? And it's just been split into one row for A and one row for Robusta. So separate rows splits stuff downward, and separate splits stuff out. Or separate rows works over rows, and separate works over columns. Okay, so that's a very helpful function. In other kinds of data that you'll see in the course, you'll have column names that have a very regular structure, such as in the Wikidata. The Wikidata has columns which say price, and then has a quarter, and then has a year. So separate can be very helpful in cleaning up data that looks like this. Okay? So going back to the species data, I'm going to get to the question about why multiple copies are generated. So I'm going to save this new data frame, which has the split genus and organism, as species. So sometimes it's good to make a new name for what you're saving the data frame for, but here I'll just use species again. By the way, the opposite of separate is the function unite. So if I were to say species unite, and I want to make an maybe species name, then I would be uniting genus and organism. And I maybe don't like using the dot space, I might do a hyphen. If I unite those two columns, then I'll get an A, and then a dash, and then a Robusta. So it'll unite the things that are on either side with the separator. And unite, just like separate, works on more than one variable. So I could say year, and then I might get a very complicated hybrid identifier. So just to show, unite is the inverse of separate. Okay, so now with these data, one thing that might be helpful would be to see if I don't care necessarily about the individual organisms, but I want to get back kind of an indicator of their prevalence, this, Hannah, is where multiple values can be generated in a pivot wider. So if I do a pivot wider on this species data, and I say names from genus, now I'm going to be ignoring the information in organisms. That means that I'm going to have multiple values for every genus. I'm going to have an observation for every organism inside of the genus. So values from is equal to prevalence. Now if I do that, it's a little hard to see. So let me drop some, let's say drop year, date, latitude, longitude. Okay, so now you can see some things. Actually, let's do positive select and just get A, C, E, G, and S. So you can see in some cases, there's a collection of lists. And this happens anytime there's multiple species in a genus. Other times, there are null values because an observation wasn't actually made of that species at that place. So if what I want to do is just get the overall prevalence, I might say the values function is sum. Oh. Right, okay, well, I need to remove that. So I might say the values function in the pivot wider is sum. And then if I do that, I'm going to select again, what was it, C-A-G-S, let's say. Then, when I have observations of species in that genus, I get a value. When I don't, I get an NA. And any multiple values, like if I observe multiple species in a single genus, I get their sum of their prevalence. So this would be the prevalence of anything in genus A at the site. Does that make sense, Hannah? If you pivot, when you pivot wider, if I pivot on that genus, I might have multiple organizations in that genus, or organisms in that genus. So I'm going to have to summarize those values in some way. Awesome. Okay. So you've seen that, you've seen unite and separate. Now, we'll talk a little bit about group bys. So species is a really great data to talk about because it's very complicated. So we've already talked about the fact that the species data frame has a bunch of different measurements and then a value for the organism at a given site. So in the same way that I did the pivot wider with the genus data, I might say, okay, what if I want to use a group by? And I group by the data to get date and genus. Oop. Oh, not data, date. So now I'm saying, okay, so for every single site where we made a measurement, I might want to summarize the total prevalence of that organism regardless of the depth. Okay? So I've got date and genus. So how many of the genus did I see on a particular day? If I summarize this, let's say my prevalence is now my sum of all of the things in that group. Then this is kind of like a long version of that wide table we made before. If I summarize this data one time, I'm going to get the average over the rightmost group, or the reduction over the rightmost group in my group by. So species into the group by, and then summarized gives me back summaries of all the genus for every date. So it's like we're stacking up the groups, and then we're tearing them down every time we use summarize. So in this first row, this is all of the A genus on this day that we saw. This is all of the C genus on this day that we saw. So group by goes forward and then it goes backward. So group by stacks things up and summarize takes them down. If I had date and then depth and genus, my new data frame would be on this day at that depth we observed 60 organisms per 1,000 ml of genus A. So what it's done is it's summarized the rightmost and given it back for every date and every depth that we have in the data. Does that make sense to everybody? Group by stacks things up and summarize stacks them down. Unstacks, I guess, as a normal person would say. The nice thing about that is that, say, if I have temps, then I might be able to say temps, actually, let's use long temps. Let's say I want to know what was the coldest temperature observed in every year. So that's the coldest temperature in every year. Okay? So let's say coldest is equal to that. So that's the year and that's the coldest temperature. Now, if I wanted to summarize again, I could, because summarize is going to take everything off the stack that it can. And once you get to the bottom, it's just going to summarize the entire data frame. So group by stacks you up, summarize takes things off the stack, and then once you get to the bottom, it does the whole data frame. So if I say summarize min coldest, that is the coldest monthly temperature in the coldest year. It's the same thing as if I were to do min long temps temperature. So why would I even care about doing this particular way? Well, one thing that people are interested in climate science is the range of temperatures over a year. So I might do range is equal to the max temperature minus the min temperature in every year. So now this is the range of temperatures that I see in every year. And then I might say, okay, what is the largest range of temperatures that we see every year? 20 degrees. There is no simple way to do that in the same way without group bys. So to run that over again, if I have tidy data and I want to find the largest range over the years, I might go group by year. Okay, so now I can think, in a single year, what do I need? I need to summarize that year by its maximum temperature minus its minimum temperature and maybe we'll call that the temp range. Okay? Now, oops, it's not going to do that, right? Because it needs the whole spell. So summarize temp range, temperature minus min temperature. Okay? And then I can summarize that again to get the largest range that I've ever seen. So it's got a, yeah, that's why. Jesus. Come on. sorry, by year, summarize. So that's the largest range that you find in any year. So what this allows you to do is construct group-wise summaries. And it's really easy to work with your data in this way, because if you had to do this in Excel, you'd have to split it up, or you'd have to use their inbuilt group-by functionality. So it's a kind of a fundamental way of working with data that's called the split, apply, combine method. And you may have seen that in your reading. Group by gives you a group over which to split the data. And then the apply verb is their version of summarize. So it says, you know, apply some function to this split and then bring it all back together. Okay, so that's this pattern. Split, apply, combine. And it's in the reading. So the other thing that is kind of helpful to know is that when you get something like this data frame, normally R will sort on the groups, right? So if you see on the left-hand side of this range data frame, you know, it goes from 1900 to 1901 to 1902 and etc. What if I want to arrange that data frame differently? Well, I could use the arrange function. Arrange is kind of like a sort. It says take the thing that you give me and then sort it again based on a particular column. Okay? So to do that, we might say arrange on temp range rather than as by default, which is on the year. Now I can see that the year with the tightest temperature range was 1974. And the year at the end will obviously be the one with the largest temperature range. So I could do something like tail, which gives me the last 6 rows, to see that the year with the largest range in temperature was 1947. Alternatively, the desc function stands for descending. So I could sort by the inverse of a column that isn't my group. Okay? So by this point, you've seen how to pivot things going from wide to long or long to wide. You've seen a bunch of different ways to work with group by. You've learned that group by works by stacking things up, and then summarize works by reducing each of those groups from right to left. We've also talked a little bit today and yesterday about select and filter. The last, separate and unite. The last 2 things I'd like to show you today are very simple. One of them is the mutate function. So if I need to add a value to my data, then the way to add a column is using the mutate function. So if I had long temps and I wanted to mutate and say have a new column, and that is equal to some, I don't know, random, let's say it's equal to, I don't know, 5 for some reason. It'll take whatever inside of mutate. This will be the new column name, and then whatever collection you put here will be the new column value. So this is helpful if you wanted to do something like mean standardizing, but we won't, it's a little bit more complicated. Let's not do that. Let's do something like this. So let's say temperature in Fahrenheit might be, what is it? 9/5 times temperature plus 32. So I've made a new column that incorporates all the existing observations using this mutate function. Now, if I were imperious and I didn't want you to have access to the original temperature information, I would use the transmute function. Whoops. Transmute deletes all the other columns, and it says this is the only column that you want. So transmute takes your input and gives you back only the column you request, whereas mutate adds it to your existing data frame. Does that make sense? Cool. The last thing that I'd like to go over with you is the expand grid function, because we're going to use it a lot. Expand grid takes basically unique values and then constructs you a data frame that contains all of the combinations of those values. So let's say I was interested in describing all of the rooms in a building. Let's say, they might have white walls, they might have gray walls, or let's say some of them are really kooky and they have red walls. And then let's say the floor could be tile or carpet. If I use expand grid on colors and floor, I get a data frame that represents all of the combinations of those variables. Do you see that? If I wanted to describe a white room with white walls and tiled floor, that would be row 1. Whereas a room with white walls and carpet would be row 2. This is very, very helpful when you're trying to, say, make predictions or structured information about, say, we'll deal with some information on earnings later. So we might have a data set where we have male, female, and not reported. And we may have some information about their education, where they might be primary only, secondary, post-secondary, or PhD. And expand grid will give you all of the different combinations that you need in order to talk about the sets of those variables. Okay, so expand grid takes the information in unique parts and builds you out a data frame that's tidy, that describes their combination. Okay? So I find talking about some joins and join theory, but I recall that you guys were also lectured about that stuff last year. Left, right, inner and full joins and things like that. We don't use that stuff too much in this course just because there's no real need for it. I give you data sets that are complete and then you tend to process those. But I would recommend just, kind of familiarizing yourself basically with those concepts. They shouldn't be needed in the course, but as like a recommendation as a practicing data scientist, joins are oftentimes some of the most helpful things that you'll learn how to do. But we've talked about them before in the course, so I'm not super, and we won't really use them extensively in this course. So I'm not super keen on spending a lot of time explaining the difference between a left full and stuff like that. So at this point, we've covered all of the different primitives that I think are important to know in the Tidyverse. You've got the pivots, you've got the group by and summarize, you've got filter and select, which work on rows or columns, respectively. You've got mutate, which lets you build new columns. You've got separate and unite, which lets you split things, either strings or values or things like that. It lets you make new columns from existing ones. And then you've got arrange, which lets you sort and change order. Most of what we do in the course and most of what you are asked to do in exploratory data analysis can be done using a group by and a summarize. So if you get familiar with thinking about things in terms of that split, apply, combine idea, or grouping by a collection of factors, summarizing that smallest group in some way, and then giving me a result, it'll be very effective for your future work. If you don't do that, you're going to have to do a lot of splitting of your data. You're going to have to use subset to make a new data frame and then do what you need to on that data frame. And then do it again because you've got 12 groups. And that's a lot of copy and pasting and changing text. So I would really recommend that you learn the group by and summarize mechanics that I've demonstrated today. Are there any other questions about the text or what I've just shown you today? I'll make sure that all the code is posted in the workbook as kind of like a lecture note thing. Let me stop sharing the screen. Okay, well, if nobody else has any questions about the content or what we're doing, then just to keep in mind, the assignment isn't due until next week, Thursday. I anticipate many of you, because you're so good at R, like let me tell you, your cohort is probably the best at R that I've seen while I've been here. Most of you are very good, and even if you don't like to recognize it, you're pretty good. So mentioned tail, Emily. Yes. Aha. Yes. So head and tail are opposites of one another. Many of you learn to use view with the capital V to look at your data. And in the Tidyverse, we tend to use head, or another function called glimpse, but we won't talk too much about that. Head takes some data and a number of rows and gives you the first number of rows of that data. So the code that I've just put in the chat would give you the first 5 rows of a data frame. So if I just wanted to get the very top row, you know, maybe it's easier for me to my camera. Let me share the application screen. Allow. Okay. So head, right? So if we had species, head species gives me the first 5 rows. And tail species gives me the last 5 rows. So if I were maybe, say, interested in finding, you know, the most prevalent species, I might do something like species, arrange on prevalence, and then if I did head, that would give me the least prevalent observation, because it's going to take prevalence and sort it from smallest to largest. If I did tail, it's going to give me the most prevalent. And let's just say select year, date, organism, prevalence. So the tail is the last 5 rows. The head is the first 5 rows. So you can see how these are all ones with prevalence 0. And these are all ones with huge prevalence. So tail is the last sum number, and head is the, so the last bit is like if I just wanted 1 row, tail gives me the last row. Tail, 12 gives me the last 12. Okay? So another very easy way, if I want the top 10, I might do arrange, desk, whatever, and then get the head, or I can also use arrange and then tail. Because remember, if I throw in a descending here, it'll reverse the data frame. Come on. Cool, okay. So they're just kind of selection operators, head and tail. And they are a lot older than the Tidyverse, actually. They've been around for a long time. So, yeah. Any other questions? I've really only got time for one. So, and like I said, normally the lectures are going to be more conceptual and less code-driven, because this is not a programming course. It's just taught using R. But given that these are kind of the primitives of the sort of tidyverse language that we're going to be using, these first lectures are much more code-oriented than the last. So at the end of the day, once you get your data tidied, running a model is a single line of code. Making a prediction is a single line of code, sometimes two, if you're unlucky. Okay? So most of this stuff is just to teach you the fundamentals. Okay, with that said, I need to go because I've got another meeting. But I'm really glad you showed today. I hope that I taught you something of note. All of these different functions in the function zoo are very helpful, and they will make you a better analyst, I promise. It's been good to talk to you today, and I'll see you on Thursday. Yeah, thanks, Kate. Everybody else have a great day too.